your kind of cameras where your hands are and what you're actually opening, because it might be fun for others to briefly pause and see what you are trying to open. I'll have a live feed of the adding machine and other places. So I'm going to put the microphone down. Folks can just walk around, search for tools, look at the object that you're thinking, think a little bit about the tools you might need. And I'm just going to go in there and let's remove that board. And so yeah, let's just pilot right here. So as you can see, these are toolkits. So you can go around and search to see what you find. And the whole point of this is to become familiar with the tools you need, and then you can take the tools to the benches as well, because it might be useful to have some space for you. So you can pick something from this if you want. So tons of screwdrivers, and it tells me that we are actually not well equipped here.
Put some over there.
Yeah, so let's just put everything that we can find in. And then at the end of the day, we will actually reorganize. Hope maybe one thing you could do is go to the lab and get one of, do you know the mini kit?
Yeah.
Do you know the one we take in the field? Let's get some things, but just write for Patch Lab on it. It seems like we don't have anything here. I mean, this is probably not sufficient for people to find tools. So you can go to the shop, but just write the name that, oh, this was flat. Yeah. Yeah, it's like for most things. Okay. Yeah, let me take a look at it. Yeah, so I think sometimes you see these, the little knobs. My intuition is that you get something and you rotate that by a certain angle and it's, yeah, so now that's what I was saying about a special tool. So you could have a plier, have just some amount of grip in and then rotate. You might want something that does it from two sides. You could also just play with it, whether just the single might pop it. Here. Yeah, see if you can find a plier that wasn't finding that part. And that is one part of the thinking in some sense. So you have an intuition of a puzzle for you to solve. So don't give up on that. That's the key. And then folks can kind of spread out if you all want. And we're bringing more tools as well. So if you have very clearly, obviously, if you feel you're stuck, just ask. Oh, I love the picture of all of you opening up stuff. That's probably. So I'm seeing some folks. I'm seeing some folks still have their cameras off. As I said, this is a contact sport. It's not an observational sport. It would be fantastic if you all turn your cameras on, find the object that you're trying to open up. If you've opened up one and assembled, go to the second. Do this a couple of times. You don't have to stop at one. But it would be fantastic if folks that are listening can turn their cameras on, choose an object that you want to disassemble and just go at it. And then whenever anybody sees fun things, please do shout out and share with others.
On the way, yeah, but you would something small. Yes, but I think they're all super tiny. Yeah. Yeah, hopefully, I think we'll just grab something else. Yeah, we have to. Yeah. I would have flyers and licenses. Yeah. Yeah. I'm gonna try that. Oh, nice. No, it's
Obviously, what's broken in the belt?
Just like, I'm not them.
Not a belt anymore.
Yeah. Wait. You wanna try this one? Oh, okay. I don't know if it's small enough. Oh, actually, it works. Yeah. You might be able to use the same one. I think your screw is also just a little,
Yes.
oh, yeah, so it's kind of hard to get out, maybe we can try it.
You had the chance to watch the next level.
Yeah, this is actually. Yeah, you see, they want to find a shot. Yeah. Yeah, that's. Oh, yeah, I would. So. I believe it's not a fight girl and flat forward, but it's like.
Yeah, I was.
Like the middle. Like. It's going, yeah, I know. Yeah, so. Yeah. I think good Mine is like, I honestly, it's pretty simple. It's like designed for mechanical. So, yeah, I'm like not like technically savvy, and I was like, this is my chance to like,
Yeah.
I was like, I can do the bare, not the bare minimum, but I was like, I want something I know I can understand, Have you broken down? I think since. Yeah. What's your name, sir? Sandra? Leslie. Okay, but yeah, I remember that.
Yeah.
I'm a coacher. Oh, I'm in that class. It's like fun to like in this class. Oh, yeah, it's kind of the other lecture. Sorry, I have another topic. Yeah. I'm gonna have it after. Are you liking it? I actually, I know, or not, honestly. I'm being sarcastic, it's not optimistic. Yeah. Wonderful. Oh, you're right. I was like, you're not. Yeah.
Right on the street.
Yeah.
Yeah.
And then.
Is, this is why you need to run the numbers. What is the scale at which you operate? And then if you are stuck in a place, do talk to your neighbors to ask for help. It's a super useful thing. These are puzzles. Not social. All right. You have. Then try to draw. Okay. Oh my goodness. They're much better.
Oh, I think it's super solid. Very people try to get another color also. Yeah. It's okay. Right? Okay.
Oh, that's a tough one. Let's talk about it.
Yeah. You're wonderful, yeah. You know, like, I did my undergrad at Stanford, so I was like, that's right. Yeah. And I think it was a sack and like, you know, no, I used to live there as a kid, so. So how about you know that?
So anybody that wants to share what they might have found so far, either online or in class, you can just raise your hand, just say for a few words what you might have found. It's important to get a pencil and a paper and draw what you see so you have a rough idea of how whatever you're trying to open actually works. It also is great notes when you'll be putting it back together. But just raise your hands if anybody is stuck, and you can also ask for feedback from other people in the chat. If there is a particular thing that you can't open up, just ask.
So this might be time now to do a quick query.
It's just a way to start oriented, so library is not a concept of language guide. And if you look one, if you look the opposite way, then you have to follow it, and then there's no both. Oh, there's no one. So then you don't have any, like, you're like, because when you put one, you see a different light, because you're gonna have like. It wasn't, yeah, like, and then, oh, it's just on a little brighter. I don't know. Yeah, and it's just like it's built for a specific activity. Flip it around. If you put it, if you flip on the big lever, it got. Because your voltage is not going the opposite way, so it's gonna not power your like it's gonna power the back. Yeah, so your current is gonna start going a long way, basically, because like when they do the process, and then you basically want that, if you're gonna, you have to, all the wiring, you know that this is really crucial. And the positiveness is flowing into, so there's like a certain orientation. Yeah, so if you put the orientation, you're kind of like going nowhere. Yeah, then yeah, but you have to try to smaller. Yeah. It also depends on how they connect with each other. So I think here they're using the metal to connect them and then connect them with this. So you were right. So yeah, I guess theoretically that will see the entire thing around. Then it should work. If I like no, the other two would like because you have all of these. Like from that branch. So.
Well, can you take one of the students to the lab, get a new slide, the machine shot?
If you want to take it apart, you have to. But it's bending because you're.
So Claudia, I see your hand up. If you want to take the mic and talk about what you saw or what you've opened up so far, go ahead.
Hi Manu, I prefer a flashlight so I can see the part it belongs to by using this tool. I could take this pair of, I don't really know how they call, but they are like important pieces for it to be adjusted to the flashlight. I just found this, I think this is the most important part because this is like a circuit for it to have the electricity to illuminate because of the light it emits. Also, I have found this glass. I don't know if you can see it. And also this spring, which is important because that's how you will like press for it to emit the light.
And
You
then
okay?
is there a reflector in there somewhere?
Yeah, I think it's
Yeah.
this one. This might be the reflector.
Yeah, and then have you figured out so far what is the light source? What type of light
Yeah,
is used?
I think it might be this one because this is like the circuit it has.
But try figuring out what kind of light is it. It's probably a type of an LED. See if you can find the part number for that LED, for example.
Okay, I
Yeah,
will.
and then if you have all the parts open, some of them are widely available. You can find part numbers and do a quick Google to get a sense of, oh, if I needed this part, how would I find this particular part?
Okay. Okay, yeah, I get it. Thank you.
Okay, I'm seeing lots of hands. Maybe I'll choose someone who has not talked in the class before. So Rushil, you're next. Go ahead.
So I did open my Bluetooth earphone and I got to a lot of it. I found the speaker, I found the battery, and then it's just a pretty small chip. And I'm trying to read the very small numbers on it by zooming in my camera so that I can realize what chip number it is.
Yeah,
But
try
even at
finding the
10x
parts.
zoom,
Is this the Bluetooth headphones?
yep. And even though I zoomed in a lot, I still can't read what's written. So I'll try to figure out a way.
Yeah, you need a microscope. Try also looking at the speaker itself. There is a voice coil inside it. So if you try opening it, you should be able to see this magnetic coil, a small magnet and a diaphragm. Just play around to see if you can find how a speaker actually works. Okay, I am seeing Dia's hand. So Dia, go ahead.
So I don't really have tools right now, and the only thing I managed to open is this mouse. So I figured out that these two little red things I used for clicking. Um, I also realized that the scrolling is done based on the rotation of this. So this might be some kind of sensor. I'm trying to I figured out that when you move below it, so that the cursor moves, the light glows brighter. So I'm trying to figure out how that light glowing brighter translates into the cursor moving on the screen.
And I'm seeing your mouse has a wheel,
Yeah,
right? And if it has a wheel, it must record the degree of rotation in that wheel. So you should try figuring out how does it know how much the wheel has moved.
right. Okay.
Yeah, yeah. Oh, this is fantastic. Okay, we'll keep going for a little bit. I'm gonna try to open my adder machine. I haven't made much progress. So I'm gonna see if I can open, and then I'll call on people in a few minutes again. If you open one thing, you can move on to another too. This is about practice. So if you've understood one thing well, put it back together, take lots of pictures, and then start on a second object that you might find. Something very different from the first one that you opened. Remember, this exercise is much more about trying to find parts and components for your projects and, use what has already been figured out in the way that you might want to use it in another project.
You open the smoke alarm? There's gotta be a way to do it.
Yeah, that's what I was trying to figure out. Like,
Yeah, I can see there. They can folding place as a snap fit, right? I don't care about it, right? Or this is functional like going back order. Okay, let's not break it. Actually, then maybe we don't open this one because you're gonna be depending on this for your life.
Well, this has been sitting in somewhere for a bit, but yeah.
But is it, do you use this as a smoke alarm in your home now? Currently, yes, but you don't know.
It works, it's just out of battery.
Oh, I see, okay. So, yeah, it makes sense to not really take explore things. Yeah, I think because it's a real device, you don't want to depend on it to say, oh, and then, or, there was a fire alarm. Yeah, you know what I mean?
Yeah. So I'm gonna see if there's a different way that I can break it,
Oh, yeah, I think sometimes because our paper devices, they don't want people to, manipulate it. And that could be the mechanism in place. The only way you do it is by breaking. So let's think about a lock. That's an important one because. Oh, is that what you guys are trying to do? Right. This object is by design, don't want it to be able to open, so this is gonna require a lot of force. There is no glue joint here as compared to the ones down here. Sure. I mean, technically, well, yeah. By design. But it would be very cool. Yeah, see, go back for absolutely, anytime. Always here. Trying to take anything off. Possible.
Yeah, very cool.
I think the challenge.
Yeah.
Engagement. You have to only be excited about the problems, but also have a good time. That's something that you have to slowly figure out how to do. Absolutely, help me, and I know I've opened it before, so I know it's doable. Cover does come off. No, I think I want to remove the rack itself.
Oh, yeah, I thought that's all.
They are
So.
the right school that I use.
I think basically. Functional. Yeah, it's functional.
Yeah, see if you find a finer.
I think it's.
Right.
Where's the actual lighting? Yeah, it's nice. I don't know what it was. Yeah. That's okay, if you want, you can try to go. Yeah, yeah. Like this thing. Yeah.
That's too, not wide enough. Remember, it was made in a different era. It was the feasible.
Yeah. 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 I really love it. I'm very hot. Yeah.
No, I think.
I thought like I guess it's like all the time, Yes. Yeah, so, yeah, I don't think the lines are biased. So then you're like, that's what makes it. Yeah. Yeah.
Oh, but,
But yeah, I think that's why.
But I have not seen. Like the typewriter. It could be.
I'm not.
I hope it didn't.
It goes for her. Unfortunately for you. Yeah. So she was. And we have our kid.
But I brought it for the opening.
I grew up in Singapore, but
Carry over mechanism, carry over that. Yeah. This one, that's how she was thinking.
Yeah.
No, I do know which was.
But I
Can't do like, oh, this part doesn't match this. Like,
Yeah, so I won't. There was nothing really challenging about it, just but it was just like here after like the first one that I did, I know like when I came here, I didn't know like very simple information. And then there was very separate people. Yeah, so it was like.
the context, so when it.
Yeah, I saw. That was fun, and it was very, we did so much. Yeah.
That's the Syrian.
And then I've also worked with environmental in 30 years of work. So that was one of the times where the refugees that got me really good.
I think we just don't have it.
You guys also put together stuff? If you're done with one, just move to another object also. It is useful to try, especially if you open up a mechanical then go to something that's more electronic oriented. Also do identify the part and then go online and see if you can find those parts. It's important to learn to say, oh, I have these batteries now. Here, this is all. Sorry.
Yeah.
These are all OEM parts. You wanna know that, oh, how do I find out? Make and model that LED source. Where do I find it? It's valuable. Because, you have a sense of.
Oh, did it?
And then either things carefully. Certain limitation on what you can design or make. Because of this process and value. Yeah, I must have been. Yeah, you can else fuse. You could, you could also fuse many other things.
Yeah.
So it's kind of not like, you guys got it? Almost, one remaining. I think so. This is where the mechanism is mounted on the plate, but we are really getting this off. And I remember I got that off, and then there is one screw here, and then the entire shell. We are so close. Just literally morning coffee.
We're like,
So I see a few hands up. If anybody wants to talk about some things they've opened, I see Meghna, your hand is up. If you want to just share what you opened. So Meghna, you can unmute yourself. Yeah.
Okay, so I tried opening up an LED table lamp. This is not working. So I shut off from the base, and I hope you can see the video. I removed the case and I found a few parts inside. And I believe this is the battery. And this is the charging slot, and this is the indicator bulb. There's a small chip over here. And
So is this a rechargeable lamp?
yep, it's a rechargeable lamp.
I see.
Yeah. So
Ah, you're right.
yeah. So here there's a switch, and this had an external part. I removed it. This is the external component of the switch, and
And
this
Meghna, does this also have a solar panel somewhere?
no, this is no.
I
This is
see. No,
electric-
it just, you charge it and then it stores charge for some time.
Yeah,
I
that's
see.
it.
Yeah.
And this is the switch, and this can be slided. And as I said, I removed the external plastic part, and I see a few wires connected to the battery.
And one thing you should try to do is look at the components on the board and
Yeah.
see if you can identify them and find online what do those components possibly do and what their sources might be.
Yeah, sure.
Yeah.
Yeah. Also on the other end, I removed the case and found this LED panel.
Oh, that's fantastic. It's an LED array.
And I saw the wire inside connecting the two. Yeah, that's it. I think there's a wire, there's a couple, two wires.
Yeah, 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 yeah,
Okay, like,
yeah. And then you're gonna try to fix it, I'm assuming.
yeah, it's going to be easy. It is very easy to disassemble. So I hope it's going to be easy to assemble it back.
Okay, Mrinal, I see you laughing and smiling. I want to hear, what are you up to?
I don't think I can fix this.
Oh, this is the pulse
Yeah.
ox?
So, yeah, it's a pulse oximeter. Yeah, I can show
Yeah.
you the parts. Just a moment.
Yeah, yeah, yeah. Go ahead.
Yeah. I'm guessing I think I took the rest of the parts away. Like it has two parts. Then this one had a rubber bush. I think it was like when you put it in the finger to provide it with like a cushioning effect. So, can you hear me?
And then do you know in terms of the
Yeah.
the
Yeah, I was-
readout, what wavelength is it using?
Yeah,
So
I
see
see
if
that.
you can find the light
Yeah,
source
yeah, this
and
is the
then
light source.
find the exact part number for that light source.
Okay, yeah.
And from that, try to identify what wavelength is used in a pulse ox. Do you see
Yeah,
what I mean? We talked
yeah.
about light on yesterday. So there is a very particular wavelength or frequency of light that's used for pulse ox. And what you want to do is find out for
Yeah,
your
I-
LED, what is the exact frequency? So
Yeah,
we know
I
it's
read-
red light, right?
Yeah,
Because
it
red light turns
uses,
on. But what exact wavelength is used?
yeah, it uses, I think it uses 660 and 940 nanometers, like red light and infrared.
Yeah, but try finding the exact wavelength. So if you
Okay.
look at the part number and the manufacturer for the LED, and then try getting a data sheet for that, it'll tell you the exact wavelength that's used. So the idea is to go, when you find parts, find their data sheets. And when you find a data sheet, you should be able to find exactly one of the key mechanisms, for example, for how it's working. So see if you can find the data sheet for the LED. This is also true for anybody else that's opening. Try finding data sheets for some of the parts that you're excited about. You guys got it. Okay, I think. Okay. Now the magic begins.
I'm sorry, to say that.
Okay, let's coordinate. So there should be another 4 of these. They are separate files. You can see this is the tapes. Typewriting. And then you see the red and the black. So you could print in 2 colors. See that? There is red ink and blue ink. If you strike here, you get red. Strike here, you get black. Ratchet right there. You can see that this is not a gear stick, it's a ratchet. So it's directional. So somehow, when this pulls in, it tugs in here. This is a 4-bar mechanism, and then it allows this to move. See, there's a mechanical assembly here, to this 4-bar linkage to here. Things probably don't. So if one moves, you want it to move, make sure that this remains on. And so this is like a little mechanism that does that. Both of these things remain sync. Okay, but the action is all in between. You guys ready for this? Let's bring the camera. Rusha, you can bring your cell phone camera. So we're about to see a surprise if people want to come here for a second. What do we think is inside a mechanical calculating machine? Before I just open it up. Gears, what else would you think are springs? I mean, you have to remember, any calculation that you type here, it has to be able to calculate it. So there should be equivalent of a memory. There should be, you can't do a carryover without memory, right? It's, and so let's just open it up. Surprise. So look at that. So this is kind of an object from Aliens. And we don't know how to make these types of things anymore. So first of all, I don't know if you guys can see, if you all come on this side, this is a good view. And so every key, you can just all come here for the second. So every key now connects to something else that moves one of these things to be able to then finally compute. And this is all designed. Yeah, and then eventually it will print the answer. So this is the answer, this is the output, but somehow this output is connected from this input through this object. And then the question really is how would you even decipher how a mechanism like this actually works? So let's see, the problem is like, even if I press this, I don't see what changed. I have no, I mean, it's all inside. And if I was to open even one, the whole thing's gonna fall apart. So this is what I meant by alien technology, is that to a certain extent, but all of this was built with no CAD, no computers, nothing. Piece of paper, you draw and you think, and then you machine something and you assemble it. And of course, thousands of them were built because every grocery store had one. So it's not a one-off, it's not like, oh, as a technology, it's an incredibly robust technology. And, you know, this is, it's not electric. Nothing in this is electric other than one of the printing power. So there is a single motor that actually turns. You could turn it on. Actually, last time I remember it was smoke coming out. But some of you can see that there is just one single electric motor. And what I don't understand is it almost feels like there has to be a drive, which I also don't see as yet. So let's remove some of the top panels. We're going to see if we can get to the problem. Is now, if we remove anything, there is no hope of ever understanding it again, because we would remove the relationships, for example, like very, very subtle things. You see any changes in this? Oh, right there, for example. So let's just play around with it. How would you poke around at it to understand it? Also very satisfying. The clicks. So this is all sheet metal. So
It's like
and
really nice.
the
Like it just returned everything. Oh, yeah.
it resets everything.
Yeah.
So just from a manufacturing point of view, this is sheet metal machining, and then it's bent. So it's not 3D molding, it's not 3D printing, none of that existed at that time. So when you look at a plate like this, for example, it was designed and cut in 2D and then bent for those specific. The same is true for every part that you see. So there is a lot of things you can do with 2.5D. Design in 2 dimensions and bend. And then from that, every single mechanism, and from a scale point of view, it's much easier to do. So a lot of manufacturing, like IKEA style, comes from traditional sheet metal bending. A lot of cars originally were all made with sheet metal bending. So that you reduce the amount of operations. Yeah,
I was
question.
gonna ask, were these, do you know if these were stamped or milled out?
That's a good question. I think my intuition is that they were milled out. I think because this is such incredible, I have a feeling it's steel, and then stamping gets a little bit harder. But you know, there is also, so what Henry is referring to, that in 2D, you can also do manufacturing in terms of stamping. So for example, how foldscopes are made, we have a roller. It's, you know, almost, I'll show some pictures of that roller. It's like a quarter-meter roller with the pattern of the foldscope on it, and that pattern has blades. And so when it passes through the paper, it just stamps it out continuously. My intuition is that this is milled, but again, it's hard to say. And then, I think one of the things that I just really admire about this is assembly is something that you have to do in your head. Because you can do CAD for it, so I can design every one of the part, but how the hell do I think that this is how it will come together? And so, I mean, very clearly, these are mechanisms. This is connected to this is connected to this. Everything seems to be connected to everything else. And also how we could repair something like this if this comes to your store, but that's exactly what people used to do. So, I think electronics has remarkable advantage, but don't rule out mechanics in solutions, and especially totally battery-free, like the level of complexity. And in some sense, we have lost the art of design in that space. We just had a meeting, both a robotics meeting and a physics meeting at Aspen and Ventura. The subject matter of it was really about kind of the revival of thinking mechanical machines, so that you can actually implement all kinds of computing ideas in pure mechanics. And maybe I'll talk a little bit about soft robotics in the end, in which now there is a class of soft robots that you can implement the logic of the robot also in a 3D printed object. So no electronics. And then suddenly the cost goes down because the actuator is printed, the logic is printed, and the sensing is printed. And it's a single monolithic piece of rubber. So there's a huge space in terms of now turning some of those ideas into useful stuff. I think the problem with the field of robotics is that they keep making cockroaches and spiders. It's like, we've had enough of that. We should make useful things. I mean, they are good demonstration. They're like hello world programs in computer science, but we moved away from hello world programs. Yes.
Just for the people here, there's a good soft robotics class, that teaches all that as well. I mean, 303 is really.
Yeah. Yeah, and I think there is a lot of molding techniques and other threads. So that's a very good thread on the technique side. And one of the things that I want you guys to think about is to take principles from these sets of fields, but actually apply them to solve problems that we need to solve. Okay, so maybe what we'll do is how much time do we have left? What time is it now?
45.
Okay, let's do 15 more minutes of trying to decipher if we can decipher. If you guys can reassemble back what you were assembling, that's also useful. If folks want to talk about any surprises, like I'm actually quite surprised how many parts that pump had. Have you figured out what all those pump parts do?
So I have theories.
Okay, why don't we go to his desk and just talk about pumps for a second? I'm gonna give this camera back, and one thread that's useful is for the folks that just saw the adding machine, think a little bit about how that works. Now you're allowed to search on the internet as much as you want. I will share the part number for this. So here is, it's the Burroughs, I love, protected by US and foreign patent. Burroughs Adding Machine Company, Detroit. So that's the machine. See on Discord if you guys can figure out how this machine works. And, if somebody wants to, this is a project in terms of being able to make a CAD for even a small portion of the machine. So I'm gonna put the phone down for a second now. Like we can just leave, right? Or, yeah. Or actually, no, let's move to the other. Let's go to your benches to just see if you can explain what you opened up and what did you learn. So this happens to be a bike pump. Parts. How many total parts does it have?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I mean, there are like a couple of parts here, but I can't separate them, but maybe like.
So that's like 30 or so parts, just roughly, for a bike pump. And I think the number of parts you can reduce in a mechanism, you can reduce the cost. Yeah, so let's walk through. I mean, you would have thought that this should be like your, water pistols. There should be just one plunger and that's about it. So what else is going on?
So there's a lot
First of all, where is the plunger?
this.
This is the plunger and it seals with this as a body,
Mhm.
right? And so what do you think these parts might actually be doing? Do people have some ideas? I mean, you can see that they're compliant. They're rubber-like. What is it? There is one thing that you don't want to happen in a pump. Air leak, okay, you want air to go, but if you are pumping a soccer ball with it, you don't want the air to also come back, so that there is probably some kind of a ratcheting.
Oh, that's what that's.
That's
oh,
the valve.
Okay, so
See?
never mind, it won't work without that piece. Never mind.
Yeah, because you don't want, while you do want the thing to self-seal and only allow flow in one direction. So that just kind of gives you these unidirectional mechanisms in place. Also, just one fun thing to think about, the number of materials that are used. This is a huge, and again, as some of you will think about biological applications, the number of materials that are allowed are very limited because they have to be biocompatible. If there is anything that touches a biological fluid, that narrows and makes the challenge even harder. So, for example, like even the temperature set, the thermometer, you have to convince yourself that, all of the things that made contact with the body were actually compatible. Yeah.
How do you make the unit directional flow if you're not providing like a positive pressure? So that's going one way. How do you do that?
Yeah, so the trick, and I don't know how this is implemented, one trick you can think about is you can use the back pressure itself as a source of energy. So I don't know how many of you have done ketchup bottles. Ketchup bottles have a three-way valve, like our heart, very similar, a compliant mechanism that one direction, it's gonna open up like 3 flaps. But if you try pressurizing it in the other way, the gates self-lock. So there used to be doors, actually those doors still exist, these two-way doors that you can open one way, but not the other way. But the more you push, the tighter the lock gets. So that's a very simple way of implementing a unidirectional flow that's the diode, the hydraulic diode, essentially. And then the other thing to think a little bit about would be is every one of them requires the same process that you will make this is not the same process you can make this, and it's not the same process you can make this, which is what makes these sets of things harder. And some of this is assembly, and some of this assembly is also manual, which is the hard reality of manufacturing. That a lot of things that when you're thinking about, if you can simplify, and Hope and I work on a diagnostic device that has a whole bunch of assembly, and we know the pain, and then you go back and revert that back to say, how do I design for least amount of assembly? That's a huge cost saving. Think about it. Okay, anybody else wants to jump to another? What about the camera? You want to see the camera? Yeah.
That's what we do.
Yeah, no, at least take a look at it,
Yeah.
so we know how the old film cameras
Yeah.
used to work.
So there were a lot of screws, a lot.
Hold on, you guys figured out how to open it the other way. That's really good.
So you can see I have these things here, like with the screws as well. And the mechanism that I noticed for the lens was that there were these gears that were here, and they all connected like this, and then when you turned it on, they moved, and then we're able to push the lens out because we needed that for I imagine this is important back to those cameras that you needed to be able to open them up to be able to focus, right? So I don't know if you guys like it's kind of a mess right now, but this was, I think, here at some point, and then there was a gear here as well. And then when you turned it on, it all moved together to be able to move this part that then moves sorry, I was taking out the lens already. So it's kind of stuck now, but it would have moved this lens back and forth. Not anymore.
This direction.
Yeah, So now I pulled it out because I wanted to take out the lens.
Is there a motor somewhere in there?
So this is the
That's the
motor,
motor,
that's the
got it.
motor, yeah, and then
yeah.
this is the battery that powers that.
Yeah, and then the film, where does the,
The film goes
Film goes
here,
here.
and then you roll it out,
Yeah.
and then, like, I guess
Yeah.
a picture is taken by printed on the
Yeah.
film, and then it goes into here as well.
yeah, so one thing to think a little bit about is look at just the sensor and the lens distance is actually very small, it's very close. So the back focal plane of where it's forming an image is right up against it, which is tricky to think about when you're designing an optical instrument, because you assume some focal distance, you have some space. So, you know, in our eye, there is the lens and then the retina. And to a certain extent, all of that is just in that tiny little space. And then how many parts in the lens? Is it obvious to see if this is a monolithic or seems like there are,
I
oh
was trying to take it
no,
out so I can open it
there is
up.
also an iris in there. You see it? Because no light is coming through right now. And
Maybe you can turn it on.
it still turns on.
I think so, look at, let's see.
All right. Yeah, did it?
Yeah,
Yeah.
it's making noises.
Yeah,
But it's
that-
not turning on up here, there's no output here.
Yeah, but if you can see, you don't see any light passing through here, which wouldn't make sense. So there's a beautiful mechanical iris, which is kind of what we call the shutter. Because you can't expose a film to light for too long. And so there is a mechanism, and then the manufacturing of those irises is just absolutely incredible, because they very quickly turn on. Yeah.
Is there a thing that remotes the phone?
Pardon?
Is there anything that remotes the phone?
Like
You manually
moves
do
the
it.
film.
So this part moves it, this is the spinny part that moves the film.
There's a button, yes.
Yeah, so when you, I guess when you click this, it would move this part as well, right? That's what I would assume. I have not, I didn't bring film because it's very.
Yeah, I think it's motorized in this, but in your normal, most of you have used the one-time cameras, right? Yeah, they still are useful. They cost like $5 or something.
They're so expensive.
They're expensive now. because- Okay. In our days, they were super cheap, nobody wanted them. Yeah, so I think kind of one of the threads there is that this is a multi-optical element. There is an optical element here, there is an iris, and of course, there is a series of lens here. And this is what I was talking about in terms of the assembly of that. And then, of course, there is beautiful serial of lenses also in your viewfinder. So the viewfinder itself is an optical train. And one of the puzzles is that this viewfinder is completely separate from your lens. But technically, what you see is not what you photograph. But the optical axes are totally different. So then there are other types of cameras that try to give you the view from the lens itself. And then that becomes complicated, because then you have to split the beam, split the image in two paths, and then it's accurate to exactly what you see.
I was looking at like,
I think this is definitely a flash. These, could they be sunlight sensors? You should open it. I mean, if you're willing to sacrifice it now, then
I think it's.
it's already sacrificed. Yeah, then it's open. That would actually be really fun to figure out, because it is recording something also. And yeah, I mean, in terms of optical instruments, this is a very valuable camera. It's a fantastic way to give you a sense of that you don't use optical instruments without the mechanical control. So it's always off the mechanical. But you must, like, this has 1 degree of freedom, I'm assuming it has to really focus on time. Does this have any focus?
I've never used to see money on the street. Okay, so. Yeah.
Okay. Yeah, okay, let's do one last one. Anybody else wants to share a show? Why don't we do the ultra extreme of the electronic world itself? So you can tell us what that is.
Yeah, so, just, it's like a charging stand, you plug your phone in and it connect your Apple.
I don't know this, I should have mistaken.
Useful. And so you have to tear it apart, essentially, there are no like, usable, assemble level parts.
That's also by design, because
Right.
most of these companies want to make, if it breaks or anything, they don't want to repair it.
Right.
With that.
Especially this one, which is only used in their stores, they don't really care about. Like, people getting it.
Oh, they don't? No, but they don't sell these.
They don't sell these.
So you just have
That
those.
is that.
Yeah.
It's- And so.
That's even more fun.
I don't really know what all this.
So I think that we have to think a little bit about the main part time you find electronic components. So first of all, these are PCBs. We will do a class where you just get a chance to build and design. It's a very straightforward open source tools to design them. But one important thing is sit under a microscope and try listing sets of components. And so if you, some of you have not taken any electronics, so those are resistors, for example. This is called surface mounted part. And it's a little bit tricky. How would you even assemble something like this? But this type of assembly reduces cost dramatically because there is a robotic machine, a pick and place machine that puts every one of the parts. And then this thing goes into the oven and using surface tension, it all kind of melts. So effectively, this thing can be made with zero human intervention, which is really what makes this possible. You can see tons of these individual little bits are resistors. I can see some capacitors here. And then of course, there is tons of what are called ASICs, which are custom chips and custom ICs. And one thing that would be valuable is if you just sit at, do we have a dissection scope here? That would be ironic to not have a dissection scope in the lab space. I'll bring a link if you don't have a, try seeing if you can find certain sets of these parts. Also, you have to remember the thermal management of these things is super important. So this thing that you're seeing is not, it's a giant heat sink. So I'll let you guys touch it. It's this sticky material that is made out of a single injection molded metal piece. And you need to get heat out for any charging. I mean, in general, lots of parts, you want to make sure that the heat is out. And that's sort of what probably drives the assembly. Effectively, there are no holes in it. This might be an isolation. Again, another example of sheet metal bending. So it was cut into B and then bent in a specific way.
Based on.
So it could have been a protection, basically, right?
This is something that.
Yeah, it could be that this is a little bit about creating the airflow between inside. It's possible, and actually most likely if there is a thermal thing here, that there was airflow design for this, that people did to confirm that this might apply. I wonder what this look like insulator.
There was a sticky substance on here, so it sticks to the table. This was just.
I see. So this is then bringing so. And even just a tiny little thing, you think about as the connector itself. So you can see these are called ribbon cables. These are really useful or very high density interconnects. So they are much smaller. So you can see this is a Kapton connection with probably 20 or so cables going in, so you can get signals in and out. Most of these things are gold plated. So we will talk about kind of electronic waste a little bit, and this is one of the challenges is that the approaches that we've taken, it's very difficult to get materials out of this at the raw material pack. Just in some sense, it makes the assembly easier, costs lower, but then none of that material goes back. What are these little, these screws, really screws? Yeah, screw that.
For the audio.
Oh, I see it. Yeah. Where are the cables for the audio? It's fine, it's like, it's plastic, but there could be a cable. I think the way that it sits on it, that would be connects. Yeah, yeah, that would be the connecting thing. Okay, I mean, one of the threads is we should spend a little bit of time cleaning up. So the sets of parts that you brought, bring them home, show them to other people, other friends, don't just toss them out. If you can, try rebuilding it back again. We'll kind of go back and forth on this, but I think the idea is try noting down the parts that you found, because we will be scavenging for a lot of parts and ideas when you're thinking about the project, especially when you're trying to prototype. It becomes very useful for you to have a sense of like, oh, I've seen something like this before, can I borrow? So this is sort of an exercise that everybody should just do in general. You didn't have to do it here. It's good to do it collectively, but do it a couple of times for different sets of parts. And then if you document, take some pictures and post them, and that would also give someone else a chance to learn. So I think we'll kind of create a space for people to post on Notion or Discord. You can just create a little PDF, share, this is what I saw. And then if you're stuck somewhere, here's a puzzle I don't understand. Like that thing is a puzzle that I don't understand. I'll just post a whole bunch of pictures, and then somebody else might think about it and say, oh, I get it. This is how. Okay, so we're gonna call it a day. Make sure you clean up your benches completely. All the tools go back. This is an awesome kit. Without this kit, use this with yours. Without this, we would not have been able to open that. So thank you. And then for the folks that are online, I wonder if anybody else wants to share what they might have seen. Any surprises? Try documenting some of the threads that folks have built, so you have a good sense of it, and then other people can also share. And I think what I was telling everybody else before, this is not a one-shot exercise. So try doing this a couple of times, so you have a better sense and a little bit of a habit of associated with what you might find in terms of parts. Do try to put it back together again, because it will give you a greater sense of what it takes to have things to be reliable. And then try posting some of those pictures online on Discord. Let's do a channel dedicated to assembly, disassembly, or disassembly, assembly, or lab one.
I think we already have a lab one channel.
Yeah, lab one, you can just put a title on it.
Yeah.
And then let's have folks. And then if you're posting some pictures, try writing something around it. And try finding some of the components and parts also associated with it. And then I will send out a message to all the folks physically here this weekend to see if we might want to move the class half an hour early, just so that you all can also get some sleep. But I don't know how that's gonna go, so we'll figure that out.
Oh, we sent the poll already.
It's already done,
Yeah.
and the answer is?
Oh,
Oh, you don't
not
know the
everybody
answer.
has filled it out.
Yeah, so the poll is out, we'll figure out and we'll let you guys know. So we'll say bye now, and we will see you on Tuesday. Bye, everyone. Yeah,
Bye-bye.
looks
Thank
like
you so
this
much.
works.
Okay, cool,
Yeah.
yeah. I
But
think
can this be used in there too? What I don't like is that you have to carry it around.
Yeah,
we're
we're
gonna
we're
get
gonna figure out the other
this
one.
one to work, which you can just click
Yeah.
on.
I think that would be the ideal.
Yeah.
Yeah, because audio is so critical sometimes for
Yeah.
what people are going to hear and see. And then hope the tools from the lab versus, okay, so then you can bring them back. Yeah, I'll take care of this.
Should we take some pictures of it before it goes together?